Hi guys, and welcome to this, my video on Pythagoras' theorem, which I swear to you I've recorded like 5 million times in year 9, year 10, year 11, and I swear I've done it for year 12 as well. Now, with that moan over, my name's Darren from Maths Guru. Yes, I have merchandise! So much excitement, it doesn't even start. But yes, I'm here to deliver the general maths course, of which this is part of. Thanks very much for watching. Before I get into this lunacy, can I ask a favour? Could you subscribe to my YouTube channel? It's so needy, I know, but it's Maths Guru. I also have mathsguru.com, which you can sign up to for free, and it gives you these videos and downloadable lesson notes. What do you mean lesson notes? The stuff I'm about to write on behind me. The stuff you can put in your summary book. Ka-ching! There are VCAT exam questions and so much more. Tell your mates, tell your teachers, follow me on social media, and I think that's about as needy as I get for now. Now, I hopefully will make the videos entertaining. This here is the learning objectives. That's pretty much what I'm going to try and get to by the end of the lesson. Pythagoras' theorem. Love, 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 love. Now, I teach it in a slightly different way, but again, it's up to you to decide how you are going to want to do it. Who was Pythagoras? He may have been that dude there. Who knows? All right, not a very good picture, to be perfectly honest with you. Did they not have cameras back in his day? Probably not. Mobile phones, how did they cope? How did they Snapchat or TikTok or whatever it is you guys do? Anyway, so basically, the guy who you see there is allegedly a murderer, all right? It is thought that basically he didn't come up with this and that he actually stole it from a load of his students, all right? I mean, allegedly, I don't know. We have to be careful. I don't want to upset some people out there. It sounds probably better as Pythagoras' theorem than Smith's theorem. Most people can't spell my surname anyway, but that's a whole new discussion. So, moving on. But if you look him up, Pythagoras may have been a murderer, may have actually killed people. Now, every person who does general maths knows the formula, all right? I think even my parents, who are like 1,000 years old, not really, could probably tell me that Pythagoras' theorem is c squared equals a squared plus b squared. Although they're from England and they'd probably go a squared equals b squared plus c squared. But the point of it is, why do you use that? Do you know where it comes from? Well, actually, the person who came up with this thought that, or sat there one day with a load of squares, right? Cut out a load of perfect geometric squares of different side lengths. So they had squares of 1 by 1, they had squares of 2 by 2, they had squares of 3 by 3, and so they kept going up. And believe it or not, they just randomly put these squares together to try and work out what would happen. You know, the fun of maths, yes? We have mobile phones and Snapchat, they had squares of paper. But when they started to put certain pieces together, they found that they created something called a right angle triangle, or at least they didn't call it a right angle triangle. I don't know what they called it, but they found that certain ones of these would create a triangle with a right angle, a perfect 90 degrees. And so if we actually were to turn these lines into really bad squares, and I'm so sorry about my drawings, right? If you turn around and leave comments on my YouTube channel saying they're rectangles, I'm going to cry, all right? I'm very sensitive. But what they found out was certain of these squares would create those right angle triangles. So, for example, a square of length 3 by 3 and a square of length 4 by 4 and a square of length 5 by 5 were one of these that actually made a right angle triangle. And people were like, oh, this is pretty funky, because they were really good in Greek times at working out areas of stuff. My goodness, there wasn't a dinner party that went past where they didn't turn around and say, hello, darling, shall we work out the area of that column? How exciting. Probably not. So when you work out the area of this square here, what they found out was, well, it became 25, let's say units squared. Let's leave that as 25 at the moment. When they then added or found the area of this square here, they went, oh, darling, that's 16, because 4 times 4 is 16, because we can work out the area of a square really easily. And then they went, oh, darling, I know another one. And so they did this one here, and they went, oh, that's 9. And somebody over there, I don't know, banoffee pie or sticky date pudding or whatever it was they were eating said, do you notice something, darling? Those numbers, they sort of related. And what they found was that this number here, that 9, when you added it to the 16, gave you 25. So what they found out was that areas of certain squares, that when they were added together, created these right angle triangles. Wow! So they found that 9 and 16 gave you 25. When you added those two together, it was 25. Now, again, you know, it didn't take long for someone to turn around and say, well, okay, if we call this length here C, and we call this length here, say, A, and we call that length there B, and by that I'm saying if we call this hypotenuse length C, and we call this A, and we call this B, then we know that the area of a square of side length B would be B squared, would be B times B. Oh, hold on a moment, there's a B squared. And if we know that this is A, and that is A, then the area of that square would be A squared. Oh! And if we called this C, and that length there was also C, then the area of that square would also be C squared. And that's where the formula came from. Really, all we're saying here is, if I add the area of one square and the area of another square that's basically connected to a triangle, if it's right angle, it would equal the area of the other length squared. And pretty much that's how I tend to do these questions, all right? So, again, you need to know the notation. The long side is called the hippopotamus. No, it isn't. It's called the hypotenuse. We don't call it hippopotamus, all right? In the questions you're about to do, to be perfectly honest with you, they're rarely going to call it C. We're going to call it X or Y or P or R. It doesn't really matter, all right? And actually, the good thing is that we don't care what way A and B is around either. So to try and make this even more complicated, we're not going to use C. We're going to swap A and B over. Is it any wonder that general mathematicians find maths challenging? Well, not really, because you've got Maths Guru on your side. Calculate the length of the hypotenuse in the triangle opposite. Now, again, this is how I teach my kids to do this. Yes, we draw a very quick triangle here. And what I do is I get them to draw some squares, really quick squares. And I know that this length here is that length there, so it's going to be 4. This one here is going to have an area of 4 times 4, so that's going to be 16. I've got this length here, which has a length of 10. This, therefore, would have an area of 10 by 10, which would be 100. So I now know, if this is a right angle triangle, that this plus this must be the area of that bit there. So for this to be right angle, then we know that that must have a square of area 116 centimeters. Now, what that means is that my value of C squared is 116. And I suppose this might be new learning, because what I now want to do is get rid of that floaty 2. And I can. By getting rid of that floaty 2, I have to take the square root of both sides. Now, a square root is that one there. So C becomes equal to the square root of 116. And as it turns out, I've got my calculator ready. Now I'm going to use the TI Nspire. If you've got the ClassPad, it's pretty much the same functionality. What are we going to do? We're going to hit there. Add a calculator. I'm going to go Control and the X squared button, and I'm going to type in 116, and I'm going to hit enter, and whoa, hold on a moment, my calculator hath given me funny answers. Yes, that's because it's in the strange mode. So if I go doc 7 and 2, and I want to change my calculation from exact to approximate, and if I go back up, copy that down, and there we go. Now, what accuracy have I got to do? 2 decimal places, and bearing in mind I've just done a video that talks about that. That's going to be 10.77, and I'm going to write in brackets 2dp, just so the people who are marking it know I've rounded it to 2 decimal places. Now, again, if you guys want to do it the old-fashioned way, your teachers out there might be saying, no, use the formula. We'd be going that C squared is equal to A squared plus B squared. That's C, let's call that A, let's call that B. So C squared is 4 squared plus 10 squared. So C squared is 16 plus 100. So C squared is 116. And hold on a moment, that's exactly where I got to. I did it geometrically with pretty pictures. All right, and you can do it with the algebra as well. You'll have to be guided by your teacher and is into which way they want to do it. But again, here's another example. What are we doing? There we go, there we go, there we go. Quick square, quick square, quick square. Right, that is 8 meters. So this is 8 meters. That means this is going to have an area of 64, because 8 times 8 is 64. This length here is 5, so that length there is going to be 5. So this now is going to have an area of 5 times 5, which is 25. And what do we know if it's a right angle? Well, we know that 64 and 25 are going to add together to give me 89. So that now tells me that that has an area of 89. Or that C squared is equal to 89. How do I get rid of a squared? With square root. So we now know that c is equal to the square root of 89. Cannot do that in my head. So let's do the square root of 89. Hit enter. And we get c is equal to 9 point. Do I write all those numbers down? Nope. Because the question said, please round to 2 decimal places. And so we get 9.43. 43. And in fact, don't forget your units. And I'm going to write in brackets 2dp, just to tell the examiner that I know what I'm doing with decimal places. All right, any more? Oh no, oh no. They've changed it around. Well, yes, they've changed it around, but you know, weirdly, firstly, we can change the way the triangle looks because it always confuses the life out of people, and it's just, which seems really unfair, but anyway. Now, I know that that right angle sign is actually an arrowhead pointing to what my longest side is. Doesn't matter. We can write it this way around. So what I'm going to do this. Oh, nope. Let's rub that out. Let's go that and that. All right, so we got this one here. We got that one there. We got this one here. Right, so what have we got? We're going to try and find this one here. So we're going to try and find this one here. This is called x. We'll come back to that in a moment. Oh, we know that this length here is 4.7. So this is going to be a square. 4.7 times 4.7. Can't do that in my head. So, but I have a calculator. So do excuse me guys, 4.7. My cabling is all over the place. 4.7 times 4.7. Hit enter, it gives me 22.09. And I am going to write all of that in there. So that's 22.09. I've got this side length here, which is 11. So that there is going to be 11 times 11. I know that off the top of my head, which is 121. Now, this is where there is a trick. Because if you remember, it is the area of this square plus the area of that square is going to give me the area of this square. But we've got the area of this square. It's 121. So we know that this number here plus that number there is 121. Or we can say that x squared is 121 minus 22.09. Well, again, fire up my calculator. Actually, what I'm going to do is I'm going to do some trickery. And I'm going to move my diagram over here, just so my calculator doesn't obscure things, the magic of technology. Right, so what have we got here? So we've got 121 minus 22.09 gives me that x squared, he says writing in movable thingy. So x squared is 98.91. Have I finished? No. So x becomes equal to the square root of 98.91, which equals, can't do that in my head, the square root of, copy that down, gives me 9.9. Oh, to 1 decimal place trying to trick me. 9.9. So 9.9 millimeters. Again, if you wanted to do this the hard way, you could by doing c squared equals a squared plus b squared. Now, what's my value of c? It's 11. 11 squared is equal to x squared plus 4.7 squared. Well, we know 11 squared is 121. We know that 4.7 squared, I just worked out, was 22.09. I want to get x squared on its own, so I have to take away 22.09 from both sides. 121 minus 22.09 is equal to x squared. So x squared becomes equal to 98.91. And once again, we are there with so much working out. But again, some teachers expect you to do all that working out, which is fine. That's not to say it's wrong. It's just not something I can do. And again, find the length of the unknown side to 1 decimal place. Alrighty-o, so what I'm going to do is there's my rectangle, there's my rectangle. No, actually, don't do that. Draw it out again. Don't be lazy. Ba-dum, ba-dum, ba-dum. So we've got square, square, and square. Yup. Now, we know that this length here is x. So that's the one we're going to find. So we're going to end up that x squared is equal to. Which one's my hypotenuse? Well, hopefully you're happy that that one there is my hypotenuse. So that's going to be 7 squared, which is 49. We know that, so the area of that square is 49. This one here is 5.2. So we're going to do 5.2 squared. So 5.2 multiplied by 5.2 gives me 27.04. And again, we've just got to be careful, yeah? Because remember that it is normal, he says, do my highlighter, that this one here plus this one here gives me this one here. But we've got the big square. Right, we've got the square that's connected to the hypotenuse. So in which case we would have to do 49 minus 27.04. So let's do that. So we're going to do 49 minus 27.04. Fire up my calculator. 49 minus 27.04 gives me 21.96. So x squared is 21.96. And x is equal to, again, I'm going to do this on my calculator. Hopefully you guys know how to do that now. And to one decimal place, 4.7. So 4.7, and my units are centimeters. And again, in brackets to one decimal place. Why did I choose orange to write in? No idea. Keep changing it around. Now, there are practical problems. No one likes worded problems. I know that, but there are practical problems that can be used to sort of do this. A helicopter hovers at a height 150 meters above the ground. So here is my helicopter. Here is the ground. I now know that that there is 150. And there's a horizontal distance of 220 meters from a landing pad. So here is my landing pad, and it tells me, therefore, that that is 220 meters. Find the direct distance of the helicopter from the landing pad. Now, what they're basically saying is here are two sides of right angle triangle. They want you to find this length here. So let's call it x. It is a right angle triangle. So we now know that this squared, so 150 squared plus this squared, 220 squared, must equal x squared. And the reason it's x squared is because this is my longest side. That's the one that has to be on its own, because I have an arrowhead pointing at it. Now, you're going to turn and say, well, hold on a moment. Why didn't you draw all the boxes and stuff? Well, after I've done enough of them, my brain starts to go, oh, hold on a moment. I can do this. So 150 squared, I'm going to do that on my calculator. 150 times 150 gives me, ooh, very big number, 22500. 220 squared gives me 48400, and that's equal to x squared. I'm going to add those two numbers together. I know that I'm doing this off camera, but hopefully you can do this without me having to show what the calculator looks like. And how do I get rid of the squared? Well, I square root. So I want to square root 70900. So again, just doing this off screen. The square root of 70900 gives me, to two decimal places, 266.27 and meters. Ka-ching. All right, so practical problems. Not everyone loves them, but by the time you've drawn your right angle triangle, life should be good. A rope tied to the top of a 5-meter pole is secured to the ground by a peg seam. Sorry, okay, so basically, once again, we have a right angle triangle, don't we? We've got a pole. There is a peg. That's how high the pole is. It's a right angle triangle because we've got it pointing with our right angle. What is the length of the rope? Again, what do we know? We know that because our hypotenuse is the longest side, that's the one we're trying to find. So we've got x squared in this situation is going to be that length squared. So 6 squared plus 5 squared. Right, so x squared is equal to 6 times 6 is 36. 5 times 5 is 25. Add those together gives me 64, I think. Let's just check. 36 plus 25 gives me, 61. That was bad maths. All right, there we go. So can I work out how to get rid of the x on its own, or how to get the x on its own? We square root the 61. And again, if I do that onto my calculator, how many? One decimal place, 7.8 meters. All right, so anywhere you now see a right angle triangle, you have the skills to be able to do this. Now, Pythagoras in 3 dimensions, oh my goodness, does it get harder? Well, these are fairly common questions, to be honest with you. We use them over and over again, and in the test I just gave my guys, that was pretty much one of the questions in there. Now, undoubtedly, they're going to want to ask you to find the diagonal from one corner of a cube to another. That is just a straight line. But firstly, they're probably going to need you to work out this length here. Why are they going to ask you to work out that length there? Because we end up with a right angle triangle when we do that. So we look at the bottom of this cube and we notice that actually we can work out the length from A to C, because our triangle we're trying to work out is A to D. Well, if we have the value of C, we know it's a right angle, so we have to find the length of A to C, which is this diagonal through here. Right, so find the length of A to C, correct to 1 decimal place. Well, we now know that we have a triangle where A to B is 5. So this is A, B, and C. B to C is 5, and let's call that x. Right, so we know that x squared, which is our length of A to C, is equal to 5 squared plus 5 squared. 5 squared is 25 plus 25, so that's 50. So x is equal to the square root of 50, or x is equal to, and again, hopefully you don't mind me doing this off camera, it gives me 7.1. So 7.1 centimeter to 1 decimal place. So that's my length of AD. It now goes on to say, that's my length of AC. So it then says, well, now find AD. Well, if I know AC is 7.1, all right, do I know my length of CD? Do I know this length here? Ah, it's the same as that one there. So that there is 5. And again, we got to find, well, I'm going to use the same letter X. And so once again, we get that x squared is 7.1 squared plus 5 squared. So x squared is going to be 7.1. Oops, calculator's done funky things. 7.1 times 7.1 gives me 50.41 plus 25. X squared gives me 75.41. And I'm going to skip a step because we know that we've got to square root that. So if I now do the square root of, I don't know what happened there with my calculator, so if I do square root of 75.41, gives me, what is it to 1 decimal place again? 8.7. So 8.7 centimeters. And believe it or not, that is the last part of this video, another 20-something minute video. Sorry guys, but hopefully it has been useful. Showing you lots of different ways of using Pythag and three-dimensional questions. If you can, sign up to my YouTube channel, Maths Guru. Just lets me know that people are watching. MathsGuru.com is there for you for the downloadable notes and all that jazz. And there are a lot more videos coming. So hopefully I'll see you in one of those. If not, take care, stay safe.